My name is Ramon Vela. I'm a math tutor at TSTC and I'm sponsored by the Office of Student Success. Okay, today we're going to cover how to graph a trigonometric function. And for today we are going to use the function f of x equals 2 cosine 1/2 x. Alright, now before you start, you want to obtain a couple of things from this function. The first thing is the amplitude of this function. And let me write this in the standard notation here, or how it should look in standard form. Be a cosine bx, where a is your amplitude. Your amp is going to equal the absolute value of a, which in this case equals 2. Now what your amplitude tells you is how far the graph is going to stretch on the x-axis, which in this case is the axis that is vertical. I know in most cases the x-axis is horizontal and the y is vertical, but because this is a cosine function, it would be on the x line. If we visit the unit circle here, this is the x and this is the y. And when you measure cosine, it is points on the x axis here. And we're also going to need to find the period. And the period is defined as, we're going to use p for period, 2 pi divided by b, which in this case is going to be 1/2. 2 pi by 1/2, which will end up giving you 4 pi. Now what the period tells you is the frequency of the graph that this function is going to give you. Okay, at the end I'm going to pinpoint exactly what that means. It's just where the graph is going to start repeating itself. Okay, in this case it's 4 pi, so that means the graph of this function is going to be 4 pi's long, and after 4 pi's it's just going to start repeating itself. And it's important to view these functions as you would a linear function. For example, f of x equals 2x plus 1. Hopefully you know exactly how to graph that, and for this you would just use a t-table where value for x and then y equals 2x plus 1, and then you just put values here, for instance 1, 0 and -1, and then you just plot those points. Just because now we're dealing with trigonometric functions, don't lose that concept, where here we're going to do the exact same thing. It's not the only method, but the method I like to use is using a t-table. But in this case, instead of finding x values, I'm going to find u values. And I use u because we're going to reference back to the unit circle. For the unit circle, key points are usually from the 90 degrees, 180, 270, and back to 0, which is 160 degrees. But we need to view them in radiant form. So it'd be pi over 2, pi, 3 pi's over 2, and back to 0. Okay? Now, every trigonometric function will have different key points. One of the easiest ways to find key points is to just multiply the period by 1/4. In this case, we have the period being pi over, well, it's 4 pi, and then we multiply that by 1/4, which will give us pi. Okay, and you want to do that 4 different times. You want to add pi plus pi to get the other key point, which will give you 2 pi. And if you notice back here on my graph, I've already plotted this to save some time, which is pi, 2 pi, 3 pi, and 4 pi. So we have pi, and in this instance we have x is going to equal 2 cosine 1/2 x. And the algebra here, I'm just going to let you do it. And let me just erase this pi here because we have to start at the origin. So we start at 0. And so we plug in the 0 into the x here, which will give us 2 cosine 1/2 0, which will give us 2 cosine of 0, and we know that cosine of 0 is 1, so our answer is going to be 2. So here at the origin of the graph, we're going to get x equals 2, so we're going to plot that point right here. Okay, we're going to move along to our next critical point, which is going to be pi. We plug in a 2 cosine 1/2 pi. We're going to get 2 cosine pi over 2, and pi over 2 is at 90 degrees, and the cosine of 90 degrees is 0. So 2 times 0 is going to give us 0. So at pi, we have 0, so we're going to mark that point here. Now our next point is 2 pi. When we plug that in, we have 2 cosine 1/2 2 pi. That's going to give us 2 cosine pi when you do the algebra, and at pi, cosine equals -1. So -1 times the 2, the leading coefficient in front of the cosine, that's going to give us -2. Come to the graph over here, and at 2 pi, this function equals -2. We'll do the same for 3 pi. I'm just going to write this out. I'm just going to put 0, and if you're interested in seeing how, why we come to 0, I challenge you to go ahead and do the arithmetic. For this instance, I'm just going to say it's 0, so it's going to be 0 on the graph. And for 4 pi, we have 2 cosine 1/2 4 pi, which is going to be 2 cosine of 2 pi, and 2 pi equals 360 degrees, which means we're back at the origin of the unit circle. That's going to give us 2. So at 4 pi, it equals 2. So we connect the dots now. Start seeing how the function looks. It's not that pretty, but bear with me here. And that's how the function looks. Now, as you can tell, at 4 pi, the point is where the point was in the very beginning at the origin at 2. So if this graph continues, it's just going to continue doing the same thing as what the graph did from 0 to 4 pi. And that is because we graph points from the unit circle. So once we use the points that go around the circle, we just start using the same points all over again. So we're getting the same values. And that's why the graph just continues doing the same thing over and over again. Okay, I hope that was helpful. My name is Ramon Vela, avid tutor at TSDC, sponsored by the Office of Student Success.